Okay, hi everyone. I'm Jack Miller with APPA, and it's my pleasure to welcome you to today's Public Power X webinar, Data Analysis for Asset Performance, a Southern Company R&D case study. If you're having any technical difficulties, you can contact us through the chat feature at the bottom of the screen. We've muted the lines to reduce background noise, but we have time for some Q&A at the end, so please use the chat feature at the bottom of your screen during the webinar for questions you'd like me to pose to the speakers at the end of the presentation. After the webinar, in the next couple of days, we'll email you a link to the webinar recording and the presentation slides. Our host for this webinar is Minsait ACS, an Indra company, who is a leading global technology and consulting company and technological partner for core business operations of its customers worldwide. Based in Atlanta, Minsait ACS has over 40 years of experience in the utility industry and is proud to bring the broadest set of OT and IT solutions to its valued customers. Minsait ACS leaves its mark by providing solutions and services that support the entire energy value chain, from intelligent management networks and data to the commercialization of energy and new services. Its value proposition is based on innovation and knowledge of the business processes and challenges within the utility sector. Our webinar presenters for today are Giovanni Polizzi and Julia Clark. An experienced industry professional, Giovanni Polizzi holds a degree in aerospace engineering and a postgraduate diploma in renewable energy technology. Giovanni is an energy enthusiast, collaborating with the energy sector to shape the utilities of the future through digital transformation, application of IoT and the blockchain, and to see, understand, and enhance changes that are occurring in the industry. He has been internationally consulting with IT systems and business processes transformation for the energy industry in topics such as smart grids, transactive energy, industrial IoT for utilities, distributed energy resources, and conventional power generation. Julia Clark is a distribution research engineer for SCS Power Delivery Research and Development Group. She is responsible for all distribution research efforts across the Southern Company footprint and aids in helping the company find new ways to maintain a stronger, more reliable and resilient grid while the company pushes forward towards a net zero future. For the past 7 years, Julia has worked for Southern Company. She has worked in the distribution, transmission, protection, and control field services and was most recently with Power Delivery Research and Development. Julia holds a Bachelor of Science degree in Electrical Engineering from Florida A&M University and is currently pursuing a Master's in Renewable Energy and Sustainability Systems at Pennsylvania State University. With that, I'll turn it over to Giovanni.
Thank you very much, Jack. Thank you for the introduction, and thank you to our audience for participating and showing interest in this this experience that we have done with Southern Company. So let me start directly by introducing the topic of today, leveraging data within the existing data within a company to calculate the health index of assets. You can see there's basically three main domains of analysis. One is the analysis of risk of failure based on asset condition rather than age. It's definitely an improvement in respect to the typical way of doing the maintenance, which is basically based on age. The other one is to optimize the life cycle cost of assets within the routine checks of a company like a utility, and then to base maintenance and investment plans on asset conditions. This is the health index basically allows this implementation of these three domains. If we move to the next slide, we're seeing what's the concept of asset health. This graph is showing on the horizontal axis is showing time that an asset is being used, and the other one, the vertical axis, is showing the stress and strength that an asset may experience. If you think about a wood pole, this could be, for example, wind, tension on conductors. If you think about a transformer, it could be an overload. So think that these are the red lines that are shown here. Actually, let me put the laser pointer so it's easier to show up here. Sorry. So basically, these are the points of stress. The strength of an asset, so its health, is basically normally starts decaying after the asset is being used, and it reach a point where basically a stress which would otherwise be normally supported by the asset, hits the point where it generates a failure. We are trying to spot, this before actually happens. This is the normally operating stress of any asset. This would be the lifetime of the asset in the absence of this particular high stress point. So if we're talking about okay, sorry. So within the industry, the practice is when we're talking about asset management systems, we have three main systems identified. One is the more commonly known as EAM, the Enterprise Asset Management. The other one is the APM. We're talking about this today, the Asset Performance Management, and then the AIP, which is the Asset Investment Planning. The time execution, so the time scale of this system is very different. Here we're going, as we move from EAM and APM into AIP, we're talking of information that is valuable in days to information that is valuable in years. And also the output of the system basically balance information in days, information in years. So let's see what these three systems, and by the way, this is a definition that Gartner gave in 2018 when they started to analyze the asset management systems. So the EAM, the Enterprise Asset Management System, will normally use technical data, typical information from maintenance, from repair, from inspections, whereas the APM uses technical data related with process and related with the condition of that particular asset. This system generates alerts and notification. These alerts and notification can generate triggers and events in the EAM, and also provide information regarding future condition and health, so the evolution of the health of the assets. So we'll provide this information to the AIP, and the EAM also provides information to the AP regarding asset data, normally the technical characteristics of the assets, which are typically stored here. And from here, the system also provides asset data, the technical characteristics of assets. So what do we see in our practice? On this side, we have systems like ACP, Info, Upkeep, the IBM, Maximo, very known platforms that manage that information, which are market standards to manage the information of EAM. On this side, we provide two solutions. One is OneSite Intelligence, basically the solution to capture all the technical information coming either from process or from condition of assets. And then OneSite Grid APM, which is the one we are talking about today, that organizes that information to calculate the asset health index. Said this, we move into what into the polling question that we have for you to try to have a feedback from the audience. So if you could please pass the first. What we're asking here is if your organization has implemented an APM solution already or planning to do so in the next 6 months. And we expect a single choice. So it would be yes already or no, it's not implemented. So we'll let some seconds for people to answer these questions. And we'll see how the polling question goes. So we can see it from the polling. I think we can call it the end of the poll. This is a relatively new new solution. Let me share. So we're sharing the results. As you see, the no is becoming it's probably trending today. Although only half of the audience has answered. Okay, let me show. So it's relatively a. So I don't know if you're seeing the results. Let me share the results now. So I may. Okay, let me. Sorry. So this is a relatively new system. So Gartner as in 2018 defined the domain of action of APM. So these are systems that are relatively new to the industry, but that are already providing a lot of information. One of the demonstration of this is actually we've been talking to a number of customers, and we are working with the Department R&D of Southern Company. So they are looking ahead of the the common practice of the industry. So let's jump into okay, what the asset performance management does. We have two main parts of analysis. One is predictive, and the other one is asset health. Of course, we are talking today a bit about the asset health. The predictive is a more it's a more well-known practice. It's normally related with power generation, not so much with distribution. It's normally related to power generation. It does require a lot of sensoring. So you typically find it in rotating machineries, for example, compressors. You find them in turbines, and generally, or in combustion chambers. So it does require a lot of instrumentation to pull out the information, and it's almost in real time the information provided. With asset health, we're trying to determine the health of large assets. These assets are normally poorly instrumented, if at all. Um, the information that we get are normally time horizon is short to long term, and the approach we normally base is based on coefficient, based on data models and engineering analysis. So bear in mind, we're not talking about statistics in this case. Each asset will have its own, the calculation of its own asset model, and we will see how this is applied by using coefficient and a specific engineering analysis of that particular asset. In the case, although we can use the asset health in a number of sectors like renewables, transmission, distribution, facility infrastructure. We're going to concentrate on transformers, breakers, voltage, regulators, pulse. This is in particular in transformers in the presentation. So, but bear in mind there are a number of other assets that can be included in this in the calculation of asset health. So APM Asset Health, what we calculate the health index monitoring. So it's based on equipment category, and normally it does use available data. So it does not require additional data, but it does require consideration regarding maintenance, inspection, operational data. The models that we use are customizable. So there are a number of models which are already been defined, but they be customized on customer needs. And we will see this particular application in two different cases. So the health index monitoring will give us the life cycle cost in terms of the health index does fit the calculation of remaining life and the calculation of the cost of maintaining that asset into operation. The risk matrix takes into consideration the definition of failure modes. That means an asset is analyzed from an engineering point of view, and what we are trying to identify is the way that asset can fail. So not all assets, of course, can fail the same way, depending on which asset. A wood pole will fail a different way from a transformer, of course. The criticality analysis based on what's the effect of the failure. A wood pole will break and the line will be on the ground. We can have a large transformer failing, an entire neighborhood is without power. We can have a transformer that is providing energy to an hospital, for example. Then the impact of the failure is much larger than, for example, a transformer providing electricity power to a small neighborhood. And then the integration of maintenance historical data. We try to use as much information, of course, information that is already available, to try to understand what has been the maintenance processes done on that particular asset. So the risk matrix will give us the information on maintenance optimization in terms of priority, in terms of frequency of maintenance, right? So we try to base that maintenance on the health index and on the criticality of failure modes. We now move into the way, which are the models that we use. The health indexes in the application APM are taken from experience of Toronto Hydro and CNIME. CNIME it's a model that is used by in UK and Denmark. You can see here the definition of CNIME. So Toronto Hydro has been for 15 years capturing data from their asset and describing the way they will calculate the health index of assets. In our application, we put together the two methods. Toronto Hydro requires more information than C9. So blending of the two, whenever there is more available data, we can our model will rely more on Toronto Hydro. Otherwise, will be using the C9 in the application. And of course, we have our expert in Minsait that provide information like engineering analysis of failure modes, for example, assets, and and of course the client. The clients will come and they'll bring their experience, they'll bring their ideas of modeling, and this is why we can customize the models that we use. In terms of how an health index model is calculated, we have here the health index is up here. We have the monitor. Let me lower it a bit so I can see better. So we have here the health index. We have here on the second level, we have the condition parameter score called CPS, and then we have the subcondition parameter factor, and finally the signals. So we build this health index starting from bottom up. We have the inputs. The inputs provide information to the first level of coefficients. This coefficient are joined into formula to give the CPS, and then the CPS, each of the CPS will contribute to the final health index. To see an immediate application, because I can understand this can be quite confusing, to see immediate application is basically this is a line regulator. So in this case, we follow Toronto Hydro methodology for the index, and we have the three CPS are here. So one is physical condition, the other one is the health of the control systems, and then this is the overall reliability of that particular asset. In this case, in physical condition does require the visibility of different parts of the line regulator. For example, the bypass open, cabinet ground, grounding rod, etc. In the case of control system, this is specific of a line regulator. In this case, we have an auto diagnostic system. We have the auto tap blocked if it ever happened, right? And then in terms of reliability, we use information as the age, so starting from when that particular asset was in use, the loading that particular asset has been experiencing, the number of outages under which that particular asset has experienced in its operational life, and then the operating counts, such as a measure of the number of operations that the line regulator has been incurring in. Of course, you can see that this information comes from different data sources. Age will come from your asset management. Loading may come from your SCADA. For example, the outage may come from the outage management system or the SCADA also, and so does the operating count, unless there is a specific system connected to the line regulator that counts that particular, or that particular line regulator requires a physical inspection to provide that particular information. So again, we're putting together data from different systems under one single model. And this is quite an important capacity of the platform, because it does allow to join normally to do an analysis of data sets which are normally in different places in a different system in a utility. What does the homepage look like? For example, this is just an example of what it may look like, the homepage. So we have a general dashboard. We have a list of assets here, and we have a number of asset health threshold, let's say. For example, if we want to select in a particular set of assets, all those that have an health alert, we'll select the button here, and we will get the selection of the assets that have an alert on, and so as for medium health or good health. Here is for sector. In this case, we have different sectors. Imagine this could be zip codes, this could be voltage levels, for example, in the network. And then we have the distribution of all assets according to their particular health index. We also have the ongoing alert. So these are basically treated. These are assets that have been treated because they have been under alert for a period of time. Let's move on to the more detail. In this case, we're looking in particular at one single asset. We have here in this case is a transformer, so we're looking at the different coefficients that made up the overall asset. The overall asset index will be here, and this is a different coefficient that produced this final result. It's also the update date, so this is the final, the last date in which the health index was calculated, right? And then depending on the sector where we are, we have a distribution of information here. In this case, all the data is organized in a hierarchical tree. You can see here. In this case, we are showing the transformer at a power station. And then we move into a further detail of the health index that we're looking before. And we have a more specific how, for example, the CPS on insulation has been calculated, and the dates in which the data was provided to the system. So we have the salt gas, oil quality, for example, or winding double. And then we have the overall insulation, overall cooling, etc. All the different parameters that made up the health coefficient. So from an overall point of view, down to the single information that has provided the value for the CPS and so for the health index. The entire chain of calculation is readily available in the platform. Which are the modeled assets that we have at the moment? You see here we have three different, let's say, cost impact categories. High cost impact, we have, of course, the high voltage transformers. We have the breaker, we have the switch gear, and then we have a number of underground cables, for example, by miles. Same thing for medium cost impact. Again, we lower the capacity of transformers, we lower the voltage for breaker and switch gear, etc. And then the low cost, we're talking about low voltage or service voltage transformer, and then final residential, small commercial industrial customer assets, all have a low cost impact analysis. Of course, the cost impact is the cost of failure of one of these assets. So all these assets you see here have already a defined model. These models these are the models that Toronto Hydro has provided. And then thanks to our team, they've also been adapted by using the C9 methodology. Whenever we cannot use 100% the Toronto Hydro methodology. We have a second polling question here. We're trying to look into more details about the experience that you have in your own organization. We're trying to know if you could know the health. I think that the question has been cut apart. But if you could know the health index of any grid assets, which among these would have the highest priority? Select one or more as required. These are, of course, assets that have been modeled. So we're waiting for the end poll. I'm waiting for people to answer. Getting number answer coming in. At the moment, pad and pole mounted transformer seem to be the highest. Breaker and switch gear also very high. I believe people have answered already. Let's leave some more seconds. Okay, let me end the poll. Okay, so share the results. We have breakers, switch gear, and reclosers together with pad and pole mounted transformers are probably the most requested assets if the health index could be analyzed. So it's good because exactly pad and pole mounted transformers are what we're going to talk about now with Southern Company. So let me stop sharing this and let me go back to the presentation. Okay, Southern Company. So let me pass the word on to Julia for her introduction of the project and her explanation.
Hello, everyone. So here you'll just see a breakdown of Southern Company by the numbers. So we're a pretty large utility company. We're involved in the electric utility industry, gas, nuclear, wholesale power, telecom. And so for the project that we're working with ACS on, we focused on Alabama Power as our use case. So the scope of the project is we selected 100 pole-mounted transformers, and we selected a mix of healthy transformers and ones that had also recently failed. And so what we were looking for, as Giovanni already kind of spoke about, was, the health index, the point of failure, the life expectancy, and the monitoring of those. So our whole goal of this was to figure out, how do we use this data to help reduce O&M costs, and by using this data, can we, implement some type of strategy for replacement, and then use this tool in the future to kind of, help us with our maintenance schedule and things of that nature. So the data that we sent over to ACS was our usage data, weather data. We sent them some load data for all of the transformers and any maintenance inspections that we did have, and they were able to use that to kind of calculate this health index. And one of the reasons we chose ACS was because they had already had a proven model, and so it was, kind of a no-brainer for us to go ahead and go with what they had. And so this is the health index model specifically for pole-mounted transformers. And so this, the grade, well, the darkened section in the middle is where we focused our research project on. So the reliability, and then underneath that, the location factor, the loading history, as well as the age factor. And the two sections on the left and the right, we didn't really focus on, because physical condition, that's not something that we tend to track, the corrosion and the pole, how it looks and things of that nature. We don't really track those inspections in the system. And then as well as the connection insulation, IR scans, oil leaks, bushings, groundings. There is no set maintenance program for overhead transformers to look at each of those qualities and kind of make a judgment on that. So we only just focused on the reliability, because that was all the information that we had readily available. And so as you can see here, this is kind of the project plan that we've been following. So in month one, we sent them all the data, and there's a lot of data that we sent. Then they were able to build and test that. And now we're moving into the user training and monitoring analysis, and the data migration, which AWS has been gracious enough to host our information in their cloud. So as you can see here, we only sent the load data, 2 years of historic data, ambient conditions for the location. And, we didn't really have data for maintenance inspections, but if that was something that, we did have, we sent that over. And so here you can kind of see what the data we sent looked like. So you could see here on the left-hand side where you see that raw data, and we have gaps in our data that you can obviously see. So one of the cool things about this project was realizing that, our metering data is good as far as, it's giving us good enough results, but it could be better, because we had some meters that read every hour, some that were, every 4 to 5 hours. So there's gaps in that data that his team would then have to shift over to that column on the right to put in that synthetic data to fill in those gaps. So one thing that we really learned, and that we're really pushing within our company, is we need smaller increments of data. So when they process all that information, they're not having to fill in as much synthetic data.
Okay, thank you, Julia. Thanks for the presentation. So what I'm showing here is the pre-processing of data. As Julia said, the data was provided and was in kind of heterogeneous. First of all, we're talking about MI data. So MI data is not meant for maintenance; it's meant for billing. So it's accumulated hourly energy. We needed 15 minutes interval power. because we wanted to identify the stress of transformers. So when actually power went up, and when the transformer was overloaded, and of course an average energy would not give that information. The first thing that we had to do is um, filling in the gaps of data. So first of all, taking data which was accumulated, splitting into hourly information of energy. I mean energy portions, and then fill in the gaps. And this was the first processing that has been done. Where you see the little red parts. We actually used um, forecasting information to generate to fill in the gaps. This was what you see here. Basically, we apply SORIMA in 1 hour interval. Then we went into convert time-stamped hourly kilowatt hour in it's a rolling sum of ascending curves, right? And so we did the first step 3. Then we basically had all these points. You see, we had the blue points, which were the hourly information of this growing energy and decreasing energy, and we had to interpolate among this, right, to get the 15 minutes um, energy points so that we could actually calculate the power and the estimated peaks of power. Again, we use SARIMA without going to too much details about the information. We started to we aggregated and normalized information per smart meter, and then we had to rebuild the story because let's not forget that AMI information is much more recent than when the transformers were implemented. Sorry, the transformers were installed. So the team had to reconstruct the information of load of that particular transformer according to, for example, information on the growth of the population in that particular area, and with that particular that would affect that particular feeder in that particular transformer. So all this was made by the team, and the good thing is that the platform has allowed this entire process. So we didn't have at the beginning we had to use external tools, but then the tools were implemented in within the platform. So that pre-processing of data coming from raw MI data into useful data to calculate the stress of transformer is already embedded in the platform. What does the Asset Health dashboards look like today inside the company? This is an example of a particular asset that we have. Again, we have the global information on an health index with the CPS. We have in this case a map. We have the different distribution of assets according to different sectors, and then for each one of the asset, we have the control system, physical condition, and reliability associated. In this case, since the control system physical, this is in particular is a line regulator. So in this case, since this control system and physical condition were not used, we assume it's 100 as index. So this is what it looks like. Let me go into the next. In this case, this one is the risk matrix. Okay, so the idea was to calculate the risk matrix for 10 of the selected 100 pole mounted transformers. Bear in mind that we split the risk matrix into areas of good health and low risk, right? Into areas of high risk, and the lines in different sectors are very much um, related to the preferences of the customer. In this case, the Southern Company. Of course, the further we go, on the right, the higher is the risk of failure, and the higher we go up, is the highest is the impact of failure. Any asset in this area requires an immediate action. Any asset that lays down in this area will require at least an inspection, and the assets in this part here are assets that can continue to operate without any particular action taken or with routine actions taken. Particularly useful, the idea is if we consider assets along a feeder or in a particular area of the network, then this allows the company to schedule a large replacement, right, large replacement project by knowing how many assets of that particular area will fall in an area over here, right? For example, across the red and the yellow zone, if I'm already repairing, doing large repair work for all these assets in the red zone, and I find that some other assets are lying in this area, then I might as well replace them all and avoid then to do a second visit, second replacement project. So this is the relevant information that is given them to the system that we saw at the beginning, the AIP, for investment planning. Now we move into the third polling question for our audience. Let's see when the question comes up. Okay, so which among these data are readily available at your organization and easily accessible to the department in charge of asset management, engineering and standards, and maintenance? Of course, we don't know exactly in your organization how the departments are called. So the idea is this. The options are SCADA and historic. Let me scroll down. SCADA, historic data only, so only electric measures. SCADA, historic data, including operations of breakers, switches, etc. Outages, historic data, transformers, inspection data, wood poles, inspection data, MI data, none of the above, or all of the above. Let's see how the answers are given. Let's leave some more seconds that people can answer. Okay. So we're reaching, answers are coming in. So we're looking for how much of this data is readily available to your departments. Okay, let me end the poll now and let me share the results. Okay, so we have the majority of the audience is talked about indicated outages, historic data. Then we also have SCADA in terms of electric measure and operational breakers, which is typical information of SCADA. And then wood pulse inspection data is also very, very much available. MI data is less available, and then some answered all of the above, which is very good. Of course, MI data is not normally related with information that comes from the information that is required at technical level. It's more related with the building information. So normally a commercial department will handle that particular data. And we found also this in Southern Company when we were looking to have this data. And thanks to a collaboration of Julie and our team, we were able to swiftly get the information. So let me stop sharing and close the poll and move on to the next slide. This is it's a brief presentation of our knowledge in asset management for energy. The team that's worked for Southern Company, of course, has a large business knowledge. People have a lot of experience, a lot of projects, and a lot of years of experience in asset management. You can see over there 15 plus years applying mathematical models, performance analysis, 15 plus year implementing predictive analytics tools. We worked with GP Strategy, we worked with Digital Energy, in particular, GE, Digital Energy, in particular when before GE acquires Smart Signals, and then with Predix, and then with the more recent platforms. And then we have, of course, supporting technology for platforms as services, containers as service, microservice architectures. All these are practice that we have in our own group. And this is a brief presentation of the company. The company operates in the USA as Indra, as Minsait ACS. Of course, we are representing Minsait ACS here with the experience in utilities. You see a number of our customer distributor across the country. but we also have other activities as in the transportation and the financial sectors. And now I will leave time for a question, or Julia, if you want to add anything, please feel free to add any experience from the project before we pass on to the questions.
All right, thank you very much, Giovanni and Julia, for the presentation. I see we have a few questions, which I will get to in just a moment. And if anyone else has something they'd like me to ask, please type it into the chat box now. We're going to launch a quick poll. Minsait ACS appreciates you spending time with them today and hopes that you found the webinar valuable. As a thank you, if you give us permission to share your contact with this poll, you'll be entered into a drawing for a chance to win a $30 Amazon gift card. And in the meantime here, let's just get to the questions. So could you please explain why AMI data was chosen to analyze the health index of transformers?
Julia, do you want to take that in terms of why did Southern Company decide that AMI data was that, or the way we presented to your team?
Sure, I can take that. So like Giovanni said, the AMI data was really used because the way this project was presented to us was using that AMI data, but it gives you a better overall picture at the load because you can look at the usage, of all the customers beyond that transformer. So everything downstream, you're really getting a better picture of. And so that's kind of why we focus on AMI data. And, also for us as a company standpoint, is data that we already have available. And so we don't have to spend extra money on like a sensor or things of that nature to put up to then get that data. It's data we already have in our system. We're just not really using it. So that was kind of the whole point behind that. You want to chime in, Giovanni?
Thank you, Julia. Yeah, one of the things when we started to talk with Southern Company was, of course, we presented the models for different types of asset, and we said, okay, this is the best conditions for us would be to have all this, and we listed all the data that was required. As you've seen, the models require a lot of information, and the first thing that was discussed with the team was, well, we don't have all that information, especially because these are pole-mounted transformer or pad-mounted transformers, so we don't really have all that information so well organized. And so we said, okay, how can we readapt the models? And that was the team and the specialist started to analyze the model and say, okay, we can calculate the LT index by readapting the models and using the information that we explained before, the MI data, engineering consideration, location of the particular information, weather information of the past, so how that particular asset is being exposed to weather agents. And that was one of the things that said, okay, let's try to see if the LT index can actually work in the same way. And then, well, your result that you've seen in the presentation. Thank you.
All right. We got another one here. Due to supply chain issues and lead times, transformers, for example, does this increase the importance of this type of analysis for Southern Company? I think that's for you, Julia.
Yes, I believe it will, just because you'll be able to see what you need to order when. So looking at the health index and being able to have a more holistic view of the system, you can make better decisions, which will then help with that supply chain issue. So
awesome, thank you. Which different sources of data were used and what were the challenges?
So we used AMI data, and then we also sent over some the load data as well. I would say some of the challenges was trying to interpret the data that was sent over. Like I said in the presentation, some of the usage data, there were a lot of gaps. So trying to figure out, okay, if I have a meter that's sending every 4 hours, is it, a combined hourly? Is that what it's sending over? So that was kind of things that we had to really figure out. Okay, what exactly am I giving, ACS to analyze? So they knew how to move forward. If it's accumulated or that sort of thing. And so that kind of led us to start having the discussions with our metering group as far as like, hey, we probably need to have meters that read in smaller increments, like the 15-minute increments that Giovanni spoke about, just so that if this is something that, our opcos start to implement on their system, it's going to be easier if they have that data at a smaller reading.
Right. Also the technical characteristics of the transformers that were used, the location, all information is also um, relevant because it's all stored in the system. Um, so additional to the usage, the real usage of data, to the real usage of those particular assets. Um, so all that information at the end ends in the same system. So it's quite a lot of different sources to put together. Uh, and it does give, once you calculate the LT index, does give a lot of information in terms of, okay, as Julia was saying, um, actually the entire data capture can be influenced within the company, because we see that if we build good quality data, then the results can be much easier accessible and much wider so can be applied to a much wider population of assets.
So which cybersecurity issues, if any, were encountered by using a cloud environment, and how were they addressed?
Well, yeah, okay. One of the objections is, of course, when we talk to customers about the use of cloud. In this case, we decided to use AWS, thanks to the collaboration of AWS in this project, and they would be very instrumental to overcome a few issues that um, were were generated because of the well, I wouldn't say that were during a few issues that we encountered because of the high level of security that Minsait provides when we develop a cloud environment for our customers. So the team was faced with a new cybersecurity policy that was recently implemented in Minsait, and they collaborated closely with AWS to overcome um, the access to the data. And of course, the data is relevant data, is MI data with information on assets, and the security is paramount in this case. So we did work closely. Our cybersecurity experts with our architects and AWS work together to guarantee access to our team and to the team in Southern Company. Uh, I, I'm, I'm not an expert, so I wouldn't go into the details of what problems we finally encountered, but um, I would say that it was a very intense collaboration with AWS to overcome and to correctly use the tools that AWS puts into the availability of customer that use their cloud environment.
Thank you, Giovanni. What data was used to define the curve used to interpolate 15-minute intervals from the actual hourly reads?
Sorry, can you say again?
What data was used to define the curve used to interpolate 15-minute intervals from the actual hourly reads?
Well, from the hourly reads were accumulated information. I'm talking about hourly, but of course there was also other granularity. They were accumulated energy information as typical in a meter. So first of all was to bring down the value to the hourly slot of energy provided in that part. And then there was they used a number of interpolation between points to recreate the different 15 minutes interval, and basically splitting an entire hour of energy into 15 minutes. And then was the analysis of the tangent. This is very technical. The tangent that the curve would have at that point, so that actually the power could be extrapolated from that particular point. So first of all, splitting an hourly accumulated into hourly intervals, then splitting that hour interval into interpolation of points of every 15 minutes, and then calculated the tangential value so that we could actually calculate the power in that particular point and understand what was the peak power every 15 minutes that was that occurred, was experienced by that particular transformer. That's a very technical question. Thank you.
Are the applied asset models and algorithms giving correct outputs?
I will leave that that answer to Julia, if you may, because they're of course they're analyzing now the quality of the health index calculated. They're using the application. They are analyzing with the experience, also with the failed assets, with the assets that were end of life. So Julia, I don't know if you feel comfortable answering that question in particular for the project.
Yeah, I would say that that's something we're still looking into. As of right now, the results are good, but it's something that we're trying to see. Okay, if we add different components, will it change the results in any way? So we're still looking into that, but overall, what we have now, they're pretty good results.
Thank you very much, Julia.
Okay, one more question here. Could you explain in more detail the use case you pursued?
Okay, yeah, so pretty much Alabama is just a crazy territory area. So what we did was we looked at transformers throughout all of our divisions in the state, and we picked 100 of healthy transformers, and then 100. It's 100 transformers, a mix of ones that are healthy, and then a mix of ones that had recently failed, to kind of see like, okay, we know that these failed. Is there a way that we could possibly catch the failure of the healthy ones, to figure out when it needs to be replaced? So that was kind of the overall goal, is just to, okay, let's look at 100 transformers. What kind of data can we get from these transformers to implement on our system? And once we've kind of gotten to this point, is okay, well, how do we expand this data and make it more broad on the system? I hope that answered the question.
Yeah, awesome. The idea, and thanks Julia for taking that. The idea is to be able to understand in the life of a transformer which kind of stress the transformer is exposed to and is undergoing in future, and try to understand if the health index will allow. If you remember the curve that we had the health index going down, the health of the transformer going down, of the asset going down. We're trying to understand if the stress that have occurred in the past, and so they have affected the health index, and the stress that will come in the future are within the range of the sustainable range of that particular asset. The health index is trying to calculate this. So when we say that an asset is at risk of failure, high risk of failure, is we know because the stress that the asset will eventually or will occasionally incur is within or is above the health, the strength of that particular asset according to the health index. So again, this is not a predictive tool. We saw at the beginning that the tool would allow the predictive or the health index. We concentrated on the health index. The predictive will tell you that a number of parameters are deviating from the expected, and so there is an underlying potential failure. What we're trying to calculate with the health index is your asset will undergo a certain level of stress, and the health of this asset, because of the history, will probably fall below the stress level that the asset will experience. So it might not happen today, it might not happen tomorrow, but bear in mind that it will happen eventually. So consider that this asset in particular is to be either replaced or maintained. Very important information, because if we're thinking about assets that will undergo particular stress under extreme weather conditions, or during maintenance of a line that you have to divert more energy into another line, then you know that along that line there are assets which are with an health index that is below the potential stress that that asset will go through. And so that's a very important information for operation if we're planning large maintenance intervention or just planning a switching operation. Once we know that there are weak assets in a particular area, or when we know, for example, high wind condition, that we know that some assets will be stressed, like wood poles, etc. So we'd rather put less energy across the lines that have assets in worse condition than others. So health index for maintenance, but also for operation. And well, I'll stop here. I don't know if there is any other question. We're almost reached the end of the hour, so if there is another question, we can take it, or I think
I don't see any, so I think we can wrap up here. I'd like to extend a big thank you to Minsait ACS and also Giovanni and Julia for sharing this valuable information with us. As I mentioned before, you'll receive a follow-up email containing the link to the slides in the recording. Thanks again so much for joining us today, and enjoy the rest of your day.
Thank you very much. Thank you, Julia, for helping us with this. Thank you very
You're
much to the
welcome.
Southern Company team.
It's my pleasure.
Bye now.